Hello. Yes, we welcome you back to PSSB, Physical Sciences, Silver Bullet with B. Richard here. Yeah, today we're looking at this question. It's a grade 10 question. Yeah, from the topic mole concept or quantitative concept of matter. And the question says that define mole. Okay, what is a mole? A mole is the amount of substance which contains the same number of particles. The particles can be molecules, atoms, ions, as they are atoms in 12 grams of carbon-12. Yeah. Then we come to this question. It says, define relative atomic mass of an element. And what is it? Relative atomic mass of an element is the average mass of all naturally occurring isotopes of an element. Yeah, then we come to this one. It says, define Avogadro number. And what is it? Avogadro number is the number of particles which can be ions, atoms, molecules, compounds, which are contained in 1 mole of a substance. That number is fixed. Actually, it's approximately 6.022 times 10 power 23 particles per mole. Yeah, then we come to this question. It says that define molar mass. And what is it? Molar mass is the mass of 1 mole of a substance. Okay, then we come to this question. It says that calculate the number of atoms in each of the following. The first one is 5 moles of phosphorus. Yeah, how do you go about this? Okay, I need to remind you here that there is a relationship which is put forward by Avogadro between number of moles and number of entities, particles, ions, and this is it, where N stands for number of moles and capital N stands for number of particles, which can be ions, atoms, and others, and Na is Avogadro number. So when you look at what we have here, then N is known and is 5 moles. Okay, we are looking for capital N, but we know Avogadro number, and it's 6.022 times 10 power 23 entities per mole. So from here, what do? We substitute. So if you substitute in this equation, your N is 5. Your number of entities is what you are looking for, but you have Avogadro number, which is 6.022 times 10 power 23. From here, what do? We cross multiply, and you're going to have N equals to 5 times 6.022 times 10 power 23. Yeah, that is that. And this is it. 3.011 times 10 power 24 atoms. Yeah. And then we come to this one. It says that calculate the number of atoms in each of the following. And what we have here is 2 grams of carbon. And how do you go about this? Okay, here we have grams. And the relationship we have from Avogadro says N is equal to capital N over Na, where small n is number of moles, capital N is number of entities, this time around number of atoms, and Na is Avogadro number. So when you analyze this equation, what do you notice? We don't have mass anywhere. But we can get number of moles from the mass. So what do we have? There is a relationship. It says number of moles is equal to mass over molar mass. Okay. So if we use this one first to give us number of moles, what are we going to have? Oh, we are looking for number of moles. But you have the mass. Mass is 2 grams. And molar mass of carbon is 12. Yeah, we need to know that the substance we are dealing with is carbon, and carbon is 12. So molar mass of carbon is 12. So what you get out of this one is going to be the number of moles. Yeah. Now that we have number of moles, we can go ahead and use the Avogadro formula. What does it say? We have number of moles, and it is 0.167. And we are looking for number of atoms. We don't know it. But we know Avogadro number, which is 6.022 times 10 power 23. And from here, what do? You cross multiply, giving you N, which is number of atoms, as 0.167 times 6.022 times 10 power 23. And with that, I would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, with me, Richard, here. Yeah, we urge you to subscribe, to comment, to like, to share. Yeah, we believe we are simply the best. See you next time. Bye-bye.